In this video, we're going to go over C++ strings and streams. So I'm going to do a little comparison first with C++ strings. The whole motivation of this exercise is to motivate you to see the advantage of using C++ strings versus the older C relative, a char array. So in C, if you're coming from C, coming from 107 or 141, the way that you represent a string in C is using an array of characters. So the syntax for that is that you declare an array and you type it as a char, and you have to create a buffer. So you have to say like how big the array is going to be, which is kind of pain because if you want to change what's stored in that array to have different strings that might sometimes have 11 letters and sometimes have 13 letters, sometimes have 15 letters, you would need to make sure the buffer is big enough for the largest, and then you'll use whatever you need. In order to actually set a string literal into that char array, there's all these library functions included in string.h that allow you to move the data around. So one of them is string copy, which is going to basically place the string literal inside of that buffer that you created. In C++, we're not going to be using char arrays anymore, and you're not allowed to use them. It's not even an option. You should be using only these high-level concepts that C++ brings to the table, which is much more beautiful and much more elegant. There's a time and a place for C. We need it, but when you don't need it, there's really no reason to use it. So when we're working in data structures, oftentimes we're working on a higher level, and sometimes we need to go under the hood and actually use some C stuff, but when we don't need it, we're not going to use it. So anytime we're doing anything with strings in this class, we're going to be using a C++ library called string, which provides us with all the functionality of a string via an object. So I don't know, everyone's coming in with slightly different experience with object-oriented programming and using objects. So we're going to be going over it lots and lots, and you'll get much better at it. But in C++, a string is an object. So to declare it, you're going to declare the object type, which is called string in C++, and then give it a variable name. And then in order to go ahead and assign a value to that object, you're just going to use the assignment operator and put in whatever string you'd like. You'll notice that you don't have to create a buffer. You don't need to decide on a length of a string. It's all handled kind of under the hood of the string object. Moving on to C, or moving back to C, let's say that we wanted to extract the net ID from the string that we've set up here in S. How would we do that in C? So in C, if we wanted to loop through a string, which is a char array, we would set up a loop, and we would know that the last element that we need to look at can be found at location strlen of that character array. The reason that that works is because char arrays in C work by always putting a null terminating character as the last character of the char array. And so these library functions that C uses are all based on simply finding that null terminating character. So strlength is able to determine how many elements, how many characters are in the string by just finding the null terminating character and counting. And then if we keep checking until we find the @ symbol, then we'll basically be able to identify where the @ symbol is located at. And then we need to pull the net ID out. So we have S, which holds the whole thing. We have I, which tells us where the @ symbol is. So now we're going to create a second variable called net ID. Again, we need to create some buffer, so we would have to determine what the max net ID size is and use that as their buffer length. And then we'll use another string library function called strncopy, which doesn't copy until the null terminating character. Instead, it copies up until the length of the third input, I. And so that will move everything up until I from S into netID. So it's not fun. It's very low level. There's not a lot of stuff handled for you. In C++, we don't have to do any of this. And then we'll have to add the null terminating character at the end as well to the netID. In C++, if we wanted to do the same thing and extract the netID, why don't just watch how much higher level this is. So first the loop, it looks the same except for instead of using this function which comes with the string library, we're going to use a member function size that comes with the object s. So remember, s is not a primitive variable inside of C++, it's an object, and string is its type. And so objects bring with them member functions, and one of the member functions is size, which keeps track of the object size. Then if we want to find the at symbol, it's going to basically look the same. We're going to actually use that same square bracket operator, and I'll talk about that in a minute. And then if we want to set up the netID string object, then that will look similar. We're just going to call on this declaration instead of the char array. And then, like I said, objects come with member functions, and one of the string functions that's really useful is called substring. You're going to use it all the time in this class, and it just pulls out a substring. So it's going to start at I and go to length I, start at 0 and go to length I, and it's just going to pull that substring out of S, and that will get you your netID. So a couple things you might have noticed: there's fewer details in C++ code versus C code. C++ doesn't have any buffers or hard-coded array sizes. The objects just naturally adapt. It's all handled under the hood. All of that does exist actually under the hood of the C object, or the C++ object, and what's really cool is that by the end of this class you'll actually know exactly how to write a string object, and would be able to write it yourself, but you don't see it as the user of the object. And in C++, the functions come with the object itself. They're members of the object, and so they act on the object. One of the things that you might have noticed is that we did use the square bracket operator on the object. So if a string is an object, not an array, why does that square bracket operator work? Well, one of the things you're going to start getting really familiar with in this class is the C++ documentation site. The best way to find any of these things is to actually just Google C++ and then whatever library you're looking for, or even whatever function name, and it will always pull up c++.com as the first hit. When we look at the string library documentation, this is what it looks like. It tells you what the constructor and destructor look like, and all of the different member functions. What you'll notice here is that when you want to access elements inside of a string, you have all of these different member functions: at, back, front, and the square bracket operator. So the way objects work, and you'll understand this very deeply by the end of this class, so if this is confusing right now, don't worry. You basically can overwrite this operator function so that your class or your object is able to act exactly like an array. And we do that all the time. We're going to be overriding square bracket operators, less than and greater than operators. We're going to overwrite equality operators, all sorts of different things. And so object-oriented design allows you to actually, include that functionality within the class itself. So let's move on to streams. So one type of object in C++ is a string. It's a whole library that you can use as a user, and it's very nice, much nicer than a char array. Similarly, C++ offers this whole other kind of library package. It has actually a couple different libraries associated with it, but they're all called streams. Streams are ways to transfer information to and from some data source. So you use them all the time. One form of a stream would be keyboard input output. So In C, that's like fprintf or sprintf. I forget what the input in C is to get stuff from the user, but that's called a stream in C++. It's the object that we use to have that functionality. And then the other very common type of stream that we're going to use in this class is file input output, which is the same idea as getting information from a file into your program or putting information from your program into a file. So let's start with formatted output. This is output that goes to the console. So this is printing to screen. So console output stream is what it's called technically. You use the function called cout, and it's just what you call the stream that prints stuff to a screen on your computer, which is called the console. There's different things you can do with this stream. It's included in the IOStream library, which pretty much anytime you download any code, start any IDE, you'll see this library included. And it allows you to print to screen. So if you type cout with the insertion operator, any string, this will print hello world to the screen. If you add the insertion operator with ENDL, that will add a new line to the screen. This type of stream you use all the time. It's part of our programs, but it's also part of debugging. We unfortunately don't have a debugger with Memer, and so a lot of what we're going to be doing is print debugging. It works just fine for our purposes. We will use a couple of other type of software to help us determine how our code is working, like Valgrind. I'm totally blanking on the other one. Just say it out loud. I forget what it's called. Anyway, so print debugging will be really helpful for us. Now, the insertion operator is something that you can use with different streams, but when you use it in conjunction with cout, it will insert whatever is behind it into the console. Similarly with formatted input, which goes the other way, so let's say you wanted to get the user to enter in their name, you're going to use cn for console input, which takes input from the user typing on the console and put it into your program. You just reverse the arrows, and so it's cn arrows into the variable. So both of these, the insertion and the extraction operator, they're overwritten so they can work with all different types. So you don't need to only use them with strings. Play around, use them with integers and whatnot, and a lot of that is handled under the hood of this object, which again is why C++ is so powerful. This is really important with streams. Again, I'm showing you this not just because I'm like, oh, here's a fun tip about C++. You actually have to use these things in our class. We aren't going to be dealing with old C stuff. We're not going to be helping you debug code that's using fprintf or char arrays. It's not supported at all, so don't use it. It also, in a lot of cases, if you use those types of old C features, you won't pass the autograder. For example, if you aren't using cout and you're printing like a double to a screen, you might not pass if you use fprintf because it might show a different number of digits and just different things like that. So all the old C stuff needs to leave. No more using it. So let's move on to file streams. So that's input-output streams for just keyboard. The other one is files. Again, we will be using all of the things that we're talking about in this lecture in every single project, including the first one. Now, with files tend to trip people up a lot, file reading. We're going to be doing file reading in project 1, and it's probably the thing that's going to take you the longest time. I'll do some demos in the live session to show you, live coding, how you can kind of develop this code. But couple things. To do file reading, you use a different library than the input-output library. You use a library called fstream. we're going to be using two different objects, input and output files. So IF is for a file that you're reading in, and OF stream is for one that you're writing out. We'll do this later in the semester, write files, but we're going to be doing a lot of file reading to start. General workflow for files is you need to create a stream variable, you need to open the file, you need to transfer the data, and then you need to close the file. Some of it happens within other steps, which I'll go over in a second. Now, I'm going to give you two file reading templates. Despite my greatest efforts, people tend to not use these templates and try to use other things that they come up with in various ways. It's kind of a waste of time. If you just use the templates I provide, it will give you the quickest path to functional code. File reading in particular, people waste a lot of time trying to get file reading code to work when I have a template here and all you have to do is load it into your program, change the file name, maybe change some variables depending on what you're reading. This is the first example of file reading. So let's say that you wanted to read a file and you just need to read word by word. So in this example, the words are all in different lines. The words could also just be all separated, like you could just be reading like an essay that just has a paragraph of words. But assuming you want to read word by word, this is the best template. And there are several, and I played around with a bunch of them last semester, and this is just the one that works most consistently with different types of files. So you create a file, or you create a string that holds the file name, and then this is the declaration of the ifstream object. We're going to call it inFile as our variable name, and if you use the constructor that takes in the file name here, it actually creates and initializes the object for you, so it opens the file for you. So this step is opening the file. You need to create a variable to hold whatever you're pulling out of the file. And so if you're just reading words in, we're going to create a string. And then what we're going to do is we're going to create a loop, and the insertion operator actually has some return value that keeps track of whether or not the insertion was worked, whether it failed or not. And so basically as soon as you hit a spot in your file where the insertion fails, like when you get to the end of the file down here, the while loop will be false and the process will stop. So this is actually the easiest structure to use for file reading. So this is extracting. I think I called it insertion before. So this is extracting word by word. And the return value of the extraction operator will be false once you have reached end of file. And that's really the cleanest way to do it. So if you need to read a file word by word, use this file reading format. We are going to do this sometimes, but in a lot of places in Project 1 you won't be able to do this because you're not reading word by word. So for example, let's say you had a more complicated file where you needed to kind of keep line by line the data straight. So maybe the first line, or maybe each line, had a food and a person's name, and you needed to keep those tied, so you needed to do some string parsing. So in this case, where you're not doing word by word and there's string parsing involved, you're going to want to use this format. So in this format, these are all the same, but what's different is that you're going to use a while loop condition that basically checks for the end of file. So as long as you're not at the end of file, you're going to keep reading. And then instead of using the extraction operator, you're going to use the getLine function. You're going to use the stream as the first input, the place to store what you're extracting as the second input, and then the delimiter as the third input. So ours is going to be a new line because our different sections that we're pulling out are separated by lines, but it could be anything. You could be delimiting by spaces or tabs or whatever. And then in order to catch the end of file, you're actually going to check if the stream is at a fail state. And so this does the same thing as this does in this format. It's basically checking for when it hits end of file and fails. And so you need this depending on whether or not the file has a new line at the bottom or not. And so this works generally for all types of files. It also helps for files that are made on different operating systems because there's different characters used for each of those. And so that's why files are so complicated. Each operating system has different characters that it uses for end of file, spaces, tabs, and stuff, and it makes for a messy file reading. But these two will work generally for most of the things that we're doing, and if they don't work, then I'll give you a template in the project description to describe it. But this is what we're going to be using in most cases. Now, the hard part of file reading, of course, is making sure that you're doing all the string parsing. So if you need to do something here to process the string, so in this case we need to separate out the string into two pieces, you need to write a function and call the function. You shouldn't put a bunch of code in here. You really need to think about decomposing your solutions so that you don't have these huge long file reading codes. And a big part of our assignments actually will be a bunch of string parsing and file reading, especially at the beginning, and then towards the end I'll probably start providing that code for you so that you don't have to keep writing it, but it's something to really help you work on function decomposition. So that's it for strings and streams. I hope that was helpful for you as either review or new information. Thanks.